Come on. Yes, I'm live. Awesome. Okay, so today it is May 6th, 5/6/19. Okay, so we're talking about today is similar triangles and proportions. Okay, if they are similar, there are three ways we can tell they're similar, okay? So there's three theorems, okay? There really are three theorems. And again, theorems are just a fancy word for a math rule, okay? I saw that on a state test too. And it was like a theorem is a math rule that can be proved, okay? That's all it is. So there are three theorems, okay? One is simply the angle-angle similarity. If two angles of one triangle are equal to two angles of another triangle, the two triangles have to have the same shape. Have to, okay? We won't even bother with that because that seems so obvious, right? If two angles of one triangle are equal to two angles of another triangle, the two triangles must have the same shape. Now, I didn't have to say the third angle because the third angle would be a no. It would have to happen, right? 2, 2, that third one's got to be there. Does that make sense? Two of them, then that third angle would have to be equal, okay? The other is our side similarity theorem, okay? And we talked about that one. That is if all three corresponding sides of two triangles have the same ratio, and I'll slow down, let you catch up, okay? If all three corresponding sides of two triangles have the same ratio, okay? If all three corresponding sides of two triangles have the same ratio, then the triangles are similar. Similar means same shape, right? And they're proportional. So if I take a look, and I'll wait for you. If I take a look at my very first example up here, okay? And it says, are the two triangles similar? Well, first of all, we've got to be a little careful because somebody drew this one upside down. But I can tell what goes with what from just the directions. So look at the directions. See where my fingers are? Angle A has to go to angle D because it's in the correct order. Does that make sense? So angle A has to go to angle D. Has to. Angle B has got to go to angle E. Has to because it's the exact same order, right? And angle C has got to go to angle F because it goes A to D, B to E, and C to F. Okay, you guys got it? So that tells me that the 8 is going to go to the 6. Does that make sense? That means the 8's got to go to the 6. Okay, so 8 goes to 6 as the 12's got to go to the 9, right? See, I got that turned around. 12 goes to the 9 as the 16 goes to the 12, right? Let's see if I can reduce fractions. Let's see if I can reduce. A little bit of magic. Let's see if I can reduce. Can we reduce? Divide both by 2 and I'll get 4/3. You guys okay with reducing? Reducing 4/3. See the 4/3? Alright, let's see if I reduce this one. Reduce them both by 3. Divide by 3, I get 4/3. Hey, I'm getting the same ratio. See, divide these both by 4 and I get 4/3. So yes, they are definitely similar because they have the same ratio. This triangle's 4/3 as big as that triangle. Okay? So yes, and so then what's the ratio? 4/3, right? The ratio is 4/3. Okay, thumbs up. Or it could have been 3/4, depending if the camera said, well, Mr. Davies, I looked at the little one before I looked at the big one, right? We'll get the same thing, so 4/3, our ratio would have been 3/4. Does that make sense? Okay. All right, hang in there, you guys. I know. Hang in there. Okay, now, next example, okay? This is more of kind of that you would see on the state test. So it says they're similar. So I make the statement, boom, A, B, C is similar. So if they are similar, then we know that corresponding sides go together. So if I want to solve for x, what I'm going to do first is say, well, let's see, doesn't 4 goes to 12? So I'm going to say, okay, 4 goes to 12 as, let's see. So I'm going, now watch this carefully. Everybody, if you're sound asleep, wake up, sleepyheads. Wake up, it's super easy. I want you to see this. Okay? I went this to this, so now I'm going to go this to this. Does that make sense? I'm going to go 4 to 12. I'm going to go x minus 1 to 18, okay? So I just have to be consistent. Yes, there are many ways to do this. There are many correct ways to do this. I could have gone this to this equals this to this equals, say, this to this. As long as I'm consistent, okay? So I'm going to say 4 goes to 12 as x minus 1 goes to 18. I went little triangle to big triangle, little triangle to big triangle. Now, can I solve for x? Heck yeah, I can solve for x, right? So if I cross multiply, I'll go 4 times 18 equals 12 times x minus 1, right? I just cross multiplied. We saw that in our warm-up. Oh, I don't know, 4 times 18. Let me borrow that from you, okay? 4 times 18.
72.
Is it 4 times 18? Really? I should actually believe it lately. I don't. You're probably right. 72. Nice job. Equals 12x minus 12, right? You guys agree with that? I'm going to go plus 12 plus 12. So I've got an 84 equals 12x. Divide by 12. And 84 divided by 12, I should be able to do that in my head, is 7. Divide by 12, divide by 12. X is 7, right? Okay, now, I know that this side, you ready? This side is 6. Okay? If x is 7, I put 7 there, right? Right? And then this one, if I put 7 right there, put 7 right there, I'm going to go 3 times the 7 plus 1. 3 times 8 is 24. Or 3 times as big. You're right, Isaac. Okay, does that seem easy? Okay. And you will see test questions like this on the state test. Where's my sophomores? Raise your hand if you're a sophomore. Okay, state test is coming. You'll see it. You will see at least one question like this on your state test. Okay. Okay. Ready to turn the page?
Can I not?
Well, you know, it's up to you. Okay. Now. Okay. Now the other theorem we saw. The other theorem we saw. The other theorem we saw was our side angle side similarity. We saw that in our journal, right? So are these going to be similar? Well, first of all, they have the angle, equal angle, right? So I know that 100 degrees is equal to 100 degrees, okay? But what about the sides? Well, I think they're proportional. Does 4, as 4 goes to 6, is that equal to 6 goes to 9? Or is that the same ratio?
No.
4 to 6, 6 to 9. If I reduce, let's see, reduce, divide by 2, I get 2/3. Reduce, divide by 3, I get 2/3. So yeah, they are similar, okay?
Reduce, reuse, cycle.
No.
Okay. Now, they say they're similar. So, do you see two triangles? I see a little triangle, and I see a big triangle. You guys see the big triangle? Right? So, if I go 12, let's see, how long is this side? This side is 30. This side's 30. For the big triangle, isn't that 30?
Yeah.
Isn't this big side 30?
Yes.
Yeah. And how long is this side?
35.
25, but you got the right idea.
My bad. Oh my
It's okay,
god. I'm
right?
tired.
So, let's go. Let's go little triangle to big triangle. So, little triangle, 12. Let's put it over here. 12 goes to 30 as 10 goes to 25. So, what's my ratio? So, if I reduce, I get, divide by 6, I get 2/5, right? Reduce by 5, I get 2/5, okay? Last but not least, how you doing? I know you guys, it's hot, you're tired. It's that time of year, but we're going to make it, okay? So, let's do it. Let's find out the value of x. I can do that. So, I'm going to avoid the fractions as much as I can. But let's double check. I got to make sure I put them in the right order. Let's see. goes to H. R goes to, this must be H, got cut off. R goes to H. S,
Doesn't R go to D?
R goes to H, because it says so.
Never mind.
S goes to G. S goes to
Triangle, but I thought it was a D.
G. So it's actually a flip, it's a reverse. And W, that can't be W. That's got to be T. That's a bad look. Oh, there's my T goes to K, right? T goes to K. All right, let's see. So I'm going to say X, 3 minus X goes to H. You guys agree with that? These two go together? Here, let me mark it so you can see it. These two sides go together, right?
Yep.
Okay, and then I'm going to go, okay, then I can probably go 3 goes to X minus 7, right? So let's try this. So let's go, all right. I'm going to go 3 minus X goes to 8 as 3 goes to X plus 7. Okay? Can we solve for X? Boy, that looks like a FOIL problem, doesn't it? That looks like factoring and foiling, right? That looks hard.
Rather not.
Is there a better way to do that one? Heck yeah! Because why don't we just do the 5 goes to 23rds? That'd be much better. So I don't want to do that. That's too much work. That might take factoring. That might take foiling. Let's do the other. So let's go instead 5 goes to 23rds. 5 goes to 23rds. Leave my white out in here because that's just making a mess. So let's see what I got. 5 goes to 23rds. I'll write that in there. As 5 goes to 23rds. Okay, why did I change it? Because there was an easier way to do it than the way I was looking at it, right? Okay, so here we go. Stay awake for a couple of minutes, okay? Check it out. I'm even color coordinated, okay? Yellow goes to yellow. Let's just go colors, right? Yellow goes to yellow, right? Don't those two sides go together? And red goes to red. Those two sides go together, right? So I set up my ratio, and I said, okay, let's do the 5 goes to 23rds as x minus, or 3 minus x goes to 8. Now I can cross multiply and make this problem much easier. So I'll go 5 times 8 is 40 equals 23rds times 3 minus x. Okay, now how are we going to solve this?
Carefully.
You guys don't like fractions, do you?
Not really.
Can we get rid of the fraction? Let's just
Divide
get
it.
rid of the fraction. No, you can't just throw it out. Multiply by 3, right? Multiply. So if I multiply both sides by 3, good job, Isaac. If I multiply by 3, the fraction's gone. You okay with that?
Yeah.
All right, then I've got 120 equals, I'm going to distribute. I'm going to get 60 minus 20x. Okay. Minus 60 minus 60. I've got 60 equals negative 20x. Divide by negative 20x equals negative 3, okay? Now negative 3 bothers me, but I think it'll work because you can't have negative lengths. But I think it'll work. So if I take my negative 3 and plug it right up in here, this side's going to be 6. 3 minus a negative 3. I'll write it down. I'm going to have a 3 minus a negative 3, which is 6. And this side is going to be my negative 3 plus 7, which is just 4. Okay? All right. How's that? Okay. Moral of the story. Set up a fraction.